We are done with material modeling in the previous lesson, so let us move on to loads and boundary condition, under which we have overview of forces and loads, basic concepts and definition, applying load and boundary condition, defining load cases, using fields, and verifying your load boundary condition model. Overview of material. Most analysis problems involve the solution of how the model behaves in response to some action on the model, a force, a pressure, a temperature, or perhaps a magnetic field. In analysis terminologies, these actions are known as loads. Similarly, some models have certain conditions constraining their behavior. For example, at end of a cantilever beam fixed on a wall, or an adiabatic, that is non-conducting boundary in a thermal problem. These constraints are referred to as boundary conditions. In this chapter, loads and boundary conditions are frequently referred to as LBCs. The field and load cases application. The field and load cases application are used together with a load and boundary condition application. The figure here shows the relationship between these three applications. In addition to load and boundary condition, which remain constant over a period of time and over a particular region of a model to which they are applied, you can also define various loads and boundary conditions. LBCs that vary temporarily or spatially are defined using a field application. This application is described in detail later. In Patran, different individual sets of loads and boundary conditions are grouped into quantities known as load cases, which essentially constitute a separate analysis solution. Using the same model data, we have discussed load case capabilities in Patran later in this session. Basic concept and definition. The following are several basic concepts and definitions that provide important information about the loads and boundary condition application. Structural load and boundary conditions. In a structural analysis problem, you are generally trying to determine the response of a model to physical loading or specific structural behavior such as frequent response or buckling. Some of the loads and boundary conditions that may work including force, pressure, velocity, inertial loads, displacement, temperature, and contact. Thermal load and boundary condition. Thermal analysis problem which determine the response of a model and its material to determine condition include load and boundary conditions such as heat source, heat fluxes, convection, radiation emissivity, and view factor. Note that the temperature value that often form the output of the thermal analysis may subsequently be used themselves as load in other types of analysis, such as structural problems. The use of output quantities as load is supported in Patran using a field capability known as FEM fields. Fluid dynamic load and boundary condition. Fluid dynamic analysis stimulate the behavior of a flow field and feature inputs such as velocity, field, pressure, and temperature. Load cases. Load cases contain loads and boundary conditions used within a singular analysis solution. For example, one load case may represent the loads and the boundary condition for each time point in the time-dependent analysis, or a single state of load for any of the static problems. They are central to ability to perform complex analysis on an individual model or examine multiple states of loading and behavior within a same model. There is a default load case in the absence of specifying your own load cases. Contain any load or boundary condition defined for your model. Field. One of the most elegant feature in Patran is its ability to create field that describes the variation of the values of an analysis quantity, including load and boundary condition object. First one is spatial field. This is most common type of field, describes the quantities that vary spatially over the model, such as linear varying heat source, a quadratic distribution of pressure across a boundary, or a discrete set of material properties. These fields are defined using spatial equation or a tabular specification. The next one is FEM field. These fields are based on previous analysis result. A good example of this is taking the result from a thermal analysis and using them to define the temperature, load, or a structural analysis of the same model. To create an FEM field, you generate a graphic display of desired results and then place the quantities used to display the field. Next one is time-dependent field. For analysis codes that support time-dependent problems, the load and the boundary condition application applies time-dependent and frequent independent loads over the time step of a time-dependent analysis, using either equation or a tabular input to define the variation. The last one is the material-dependent field, where material properties field can be created that vary based upon a dependent variable such as temperature and frequency. These capabilities are described more fully in element properties. Applying the load and boundary condition. Within Patran, the load and boundary related information is stored in load and boundary condition sets. For each LBC set, you must define a unique name, an analysis type, and one load boundary condition object set type. The LBC sets are either static or dynamic. You can apply these sets to geometric entities or FEM entities as defined in the select application region subform. The LBC application form. The LBC application form is where you define the load and boundary condition for your model. Using the application form, you can create, modify, delete, and show a range of load and boundary condition data. To use the load and boundary condition application form, follow the steps given here and pause the video. Action. The following table briefly describes the action choice on the loads and boundary condition form. Pause the video and have a glance. Objects. The table below lists the LBC objects that are supported for each analysis type. The LBC object, also called as set types, that you may assign may vary depending on what analysis code you have selected. The table shows here mostly based on MSc Nastran analysis code. Verifying your LBC module. Error in loads and boundary condition represent one of the more subtle errors that can make place in an analysis model, as well as one of the more potential serious one. There are two primary ways to verify the load and boundary condition that you have applied to your model. Visual inspection, using graphics display to examine the placement of load and boundary data, boundary condition data on your model. Second one is numerical verification, where you examine the actual values used for loads and boundary condition in a tabular form. The first of these techniques are plot marker comes automatically with the most cases of modeling and loads and boundary condition. Wherever you create or modify LBC data, visual markers display on your model by default. These symbols are coded by color and shapes to correspond to your specific load boundary condition, with some examples shown here. These displays come in a permanent part of a display until they are explicitly clear. The display load boundary condition EL props menu may be used to manage turn on, turn off, change the color, or manage the display of these symbols. To create and modify LBC data, visual markers display on your model by default. The next one is the plot contour. For scalar values, an alternative form of display is used to plot the contours action to display a color fringe display of a load data on the surface of the model. These scalar values can either be directly scalar quantities such as temperature, or a scalar component of a vector quantity such as an X component of a applied material. To plot the contours, one of the two things are used. On the load on BC application form, set the action to plot contours and form the object drop-down menu using the load boundary condition to wish a plot. The spectrum values and color coding for these counter displays will span the range of values by default, but can be modified using the display spectrums menu. When you no longer wish to display this contour plot, select reset graphics button on the plot contour menu form. Show load boundary condition data in tabular format. To verify a load and boundary condition values numerically, you can use the show tabular action on the load and boundary conditions applied form to create a spreadsheet-like display of data for your current load case. These display and verification capabilities all permit to the current load cases. To look at results from other load cases, make these load cases current using the load boundary conditions or load cases application form. Now we have come to the end of load and boundary conditions. Let us move on to element properties in the next session.